All right, welcome back. We're doing the next one for this week. Now this is going to be talking about how we can get things into vertex form by completing the square. This is a very important skill. It is actually makes life a little bit easier than quadratic formula. But like I said, sometimes it's a little challenging because it's new. First thing that we're going to do though is just multiply this out. Again, what do you not do? You do not just square the x and square the 7. That is wrong. Again, I cannot emphasize enough how wrong that is. We are multiplying this by itself. Always remember that. That quantity is being multiplied by itself. So we're foiling this out. And this is a perfect square trinomial. Same thing with this. If we multiply this by itself, or to itself, I should say. Now here's the key with both of these. The important thing, if I want to go from here back to here, if I want to find out the value, if I want to find this value to make it so I can factor it back to this. So let's say I gave you something like x squared plus 14x plus some number c. And I want to know, and we're going to do this in the next part, but I want to know how I get that 49 from what I have here. Here's what you do. You take the middle number, 14, you divide it by 2, and then you square it. So what's 14 divided by 2? It's 7. 7 is the value that you then square, which gives you 49, which is what that is. And then when you factor it, this 14 divided by 2 number is the number that shows up in the factored form, the square of a binomial. So let's do a couple of those on this page right here. Find the value of c that makes the expression a perfect square trinomial. Then write the expression as a square of a binomial. So first things first, I want this c value. I need to take half of the middle term and square it. So half of the middle term is 3. So that's the number that's going to be in my factored form. And if I square this, it becomes 9. So this becomes, so c equals 9. So I get x squared plus 6x plus 9, which then factors down to x plus 3 quantity squared. Okay, so I took half of the middle number, squared it, that goes there, and now notice how it's a perfect square trinomial. So now I can write it as a square of a binomial. Alright, this one's not as nice. We have to divide this by 2, so we get 1.2 quantity squared. And that turns into 1.44. So c is equal to 1.44, and you can rewrite it with that in there to help you out if you want. X squared plus 2.4x plus 1.44. Now again, if you're like, oh, well, what are two numbers that multiply to 1.44? You found it up here. It's 1.2. So to write this as a square of a binomial, it's just x plus 1.2 quantity squared. And now it's factored. Again, this is a very important skill when we want to start turning things into vertex form. Divide this by 2, we get negative 5 halves. And then when we square it, we get 25 fourths. Leave it in fraction form. So my problem becomes x squared minus 5 plus 25 over 4. Now we can factor it. X minus 5 halves. Quantity squared. Again, we got that from just dividing up the 2, and this value is our c value to make this happen. This is not nice at all. We have to divide this by 2, so we get negative 3/10. This will be the value you'll use in your binomial. When we square it, we get a c value of 9/100. So if I rewrote this as x squared minus 3/5 x plus 9/100, that can factor to x minus 3/10 quantity squared. Okay, so that is how you would actually find a value to make it a perfect square trinomial. Again, we're doing this so we can make these go into vertex form to make it look a little bit nicer for us for graphing purposes and for just manipulating. And this is called completing the square. So, here's what we're going to do. I have this right here. You always separate out this negative 1, or the number. We don't want to deal with that. So, I'm going to rewrite this as y is equal to x squared plus 4x plus something else, and then minus 1, and then we have to do something here too. Here's what I did. I separated out the negative 1. I want to do what we did up there to make this a nice factorable thing. So I'm looking, this is like my C value again. That's my C value. What value do I need there so I could factor this nicely? Well, if you take half of 4 and then square it, you get, let's see. Well, you should be able to do that. 2 squared is 4. So I'm adding 4 here, so then I can write it as a square of a binomial. I just made it a perfect square trinomial. However, if you guys are taking chemistry or just in general math, you have to have a balanced equation. I just added 4 to this whole equation. I added 4 because there's a 1 out here, so I added 4. So in order to balance that, I have to take away 4 on the back end because I have to keep the equation in balance. So now I can write this part as x plus 2 quantity squared when I factored it, and this now becomes minus 5. Now this is in vertex form. I can now identify the vertex of this equation. I just converted it from standard form to vertex form by completing the square. My vertex is negative 2, negative 5. Alright, now on part B we have a problem. The problem is we have a 1/3 x in front. We have to factor that out. You can never do this with a coefficient other than 1 in the front. You have to take it out. When you take that out, it's like you're dividing it out. So when you divide negative 12 by 1/3, it actually gets bigger. Okay? And I'm only taking it out of those two things. The 92 is kind of hanging out by itself. Alright? So now I need this C value, again, that I need to add to this to make it a perfect square trinomial. So if you take half of 36, you get negative 18, and then you square it. So 18 squared is 324. So this is half of negative 36 is negative 18, and then you square it, you get positive 324. Now here is another trick. Everyone, focus, focus, focus. Am I really adding 324 to this equation? No. Hopefully you said no. And the reason why is, let's look at these things. I'm actually, in essence, adding 324 times a third, because there's that third out there. So I'm really, in essence, adding 108 to the problem, not 324, because the 324 is being multiplied by a 1/3. So I have to balance this by subtracting a 108. So now I can say y equals 1/3 quantity. This becomes x minus 18 quantity squared, because this is the perfect square trinomial that I could factor. And 92 minus 108, you should get negative 16. And my vertex is equal to 18 comma negative 16. Kind of it's opposite of what's inside and the outside. Down here we need to pull out the negative 2. So y is equal to negative 2 x squared. Now be careful, when you pull out a negative, this changes signs. And again, the 18 we kind of leave by itself. We're just pulling out the 2 out of this piece that we want to turn into the complete square. So I need to add a C value, which will then add something over here, or subtract something over here. Depends on what's happening. So half of negative 4 is negative 2, squared is a positive 4. But again, are we really adding positive 4? No, we're adding positive 4 times negative 2. I'm actually taking away 8 here. I'm adding this 4 times negative 2, which is a negative 8. So the opposite would be I have to add 8 to balance it out. I'm adding 8 to balance it out, because I'm taking away. So I write y is equal to negative 2 times the quantity x minus 2 squared plus 26. So my vertex is positive 2, positive 26. And that is how you go from standard form to vertex form by completing the square. We will also use this method to solve quadratics instead of using the quadratic formula. It's actually sometimes a little bit easier to use than doing x equals opposite b plus or minus square root b squared minus 4a squared, or 4ac all over 2a. Anyway, dazzling diver Dan dives off a 3-meter springboard. His dive can be modeled by the equation negative 2.8x squared plus 7.4x plus 3, where x is in seconds and y is in meters. So we're in meters per second. Sketch the graph. All right, let's look at the calculator for this. All right, I have the equation in my y equals. It should look like this. Now, however, we probably don't care about, think about it in terms of real life. Do I care about negative time over here? No, I only care about positive time, and I probably care about when he's above the water. So this is actually the path of the diver. So I'm going to graph this, but I need some points to graph it. I need my y-intercept, which is 0, 3. If you look back at the equation, if you put 0 in for x, you get a positive 3 out. That's where he starts. 0, 3, there it is right there. We need to find the maximum, and we need to find the maximum and the intercept. Let's do that. So whenever I sketch, I like the important information. So second trace. Now I'm going to use 4 because I want a max. It's the top of the curve. I'm at the left of it right now. I'll go to the right of it. Okay, and then I hit enter and I go to the middle. And I get the point 1.321 and 7.889. Okay, so I'm going to graph that. So here's my graph. Here's 0, 3. Here is the point 1.321, 7.889. And then he hits over here somewhere. Oh, I probably should have made that 1, 2, 3. There, we'll do that because that's 1.321. So I'm going to go back to my graph to look at where he hits. So I need to find this intercept point by doing second trace 5 and hit down. So I'm on this line here. I want to know where he hits. Hit enter a couple times. And I get 3, and then again, here's another situation on the calculator, guys. 1 times 10 to the negative 12th. That's basically 0. That's 0. So don't let that fool you. It is 0. So this is 3, 0. This is 0, 3. And this is the vertex. So the diver, and again, this is just showing his height with respect to time. So at 0 seconds, he's 3 feet. At 1.321, he hits a maximum height of 7.889 feet. And then at 3 seconds, he's at 0 height. At what time would Dazzling Dan be 5 meters above the surface of the water? So, remember, y is meters, time is seconds. So this you could just plug in. Y is equal to negative 2.8 times 5. Oh, no. I've got that flipped up. We are looking for time. We are looking for x. I want to know what x is equal to. Well, if I want to know where it is at 5 meters above, this is where you use your calculator. We want to basically figure out 5 is about here. Okay? So if you look at the graph, there's going to be 2 spots where he's 5 feet above the ground. In order to find those spots, draw that line on your calculator. Where we were drawing y equals 0, draw y equals 5 instead and see what we get. So, here we go. I'm going to make y2 equal to 5 now because I want to know when the height is 5. And when you draw that, look at the line that pops up. There's the line where y equals 5. Where it hits these 2 spots are the answers for my problem. So I'm going to hit second trace 5. I'm only going to do one of these right now. I'm going to hit enter 3 times. And the first time he's at that is 0.306 seconds. 0.306 seconds. So, x equals 0.306 seconds. And if you do it again on the calculator, you can pause right now and try it. But if you do it again on the calculator, you get x is equal to 2.33 2.7 seconds. Okay? Now, at what time would he be 2.5 meters above the surface? Now this one you should notice that that's only going to happen once. Here's 2.5. It's only going to hit there because he starts above that point. Okay? At what time would Dazzling Dan enter the water? We basically found that already. He enters the water at 3 seconds because that's when he hits. I'm going to come back to B real fast. Let's go to, so C is 3 seconds because that's when he hits the water. What is his height 2 seconds into the dive? So Y is equal to, you can just do this you can do this by hand, or you can use your calculator. When X is equal to 2 seconds, let's look at our table and our graph. Okay, let's look at the table. Second table, when X is 2 seconds, sure enough, it tells us he is 6.6 feet above the ground. So Y is equal to 6.6 feet is his height. Back to B, just draw that line at 2.5. Y equals 2.5. So I draw the line, and again, it hits here, but the first point it hits is actually a negative time. We don't care about that. We only care about this positive one. So we do second trace 5 and move over to that point. And we hit enter a couple times. And we get 2.709 seconds. 2.709 seconds for this one. Okay, again, round to 3 decimals if possible. What does the y-intercept represent in this problem? Let's look back at our graph. Here's the y-intercept. That is where he's starting his dive, so we would probably say that that is the height of the springboard, right? The height of the springboard, because that's where he's starting his dive. Alright, so I'll probably have another problem for you guys to try, especially with the modeling, but again, very important lesson before this quiz that you have to take. I think this year it's on a Wednesday or Tuesday next week. So anyway, I will see you guys later.